Good morning, dear students. Today's class we start learning about Bayes' theorem. Before I could begin with the exercises using Bayes' theorem, I would like to explain some theory part. First theory part you need is a partition of a sample space. You know, every random experiment has a sample space, and that sample space now can be divided into a set of events. Say assume n number of events, e1, e suffix 2, e suffix 3, comma so on, e suffix n. So here I have written a set of events e1, comma e2, comma e suffix 3, comma so on, comma e suffix n is said to be a partition of the sample space. Yes, say partition of the sample space. Yes, if the following three conditions are satisfied. I'll explain the conditions. So please understand, probability of occurrence of each event should be greater than 0. When we write mathematically something greater than 0, it means it is positive. That means probability of occurrence of each event should be positive, should be greater than 0. See, I have written, I will read. Probability of e suffix I, each event greater than 0. This should happen for all. See, this symbol we read for all. Say I write here. This we read for all. One I, 1, comma 2, comma so on, comma till n. That is probability of E1 should be greater than 0. Probability of E2 should be greater than 0. Probability of event E3 should be greater than 0. And so on. Probability of E suffix n, the nth event, should also be greater than 0. Second condition is when you take the intersection of any two events. In general, I have written, check, E suffix I, intersection, this symbol is intersection, E suffix j, it should be null event, impossible event. Meaning is no element should be, no outcome should be common to E suffix I and E suffix j, where I and j are not equal, they are different events. So for example, E1 intersection E2 should be a null event. E1 intersection E3 should be a null event. E1 intersection so on En should be a null event. Now take intersection of E2 with the E3 should be a null event. E2 with the E4 should be a null event. Like that. It should they should not have any two events, any two distinct events should not have an outcome in common. That is the meaning of second condition. Third condition, when you take the union of all the events, E1 union, E2 union, E3 union, see I have written here, so on, union E suffix n, we should get complete sample space. Yes. See the entire thing, the definition of partition of a sample space, if we could picturize, it looks like this. So this is the sample space. Yes. These are the events. So E1, event E2, event E3, event E4, and so on. And so on. These are all events. I not marked inside, but these are all events. Assume this is the nth event, E suffix n. So probability of occurrence of each event should be greater than 0, first condition. Second condition, any two distinct events you take, they do not have any element in common. Third condition is you take the union of all the events, it would be the sample space. After this, I would like to give the definition of Bayes' theorem or the statement of Bayes' theorem. This much I request you kindly go through. Students, now I would like to explain the statement of Bayes' theorem in general, that is for n events. So just now I explained the meaning of a partition of the sample space. Yes, assume a set containing n number of events. E suffix 1, E suffix 2, so on, comma E suffix n be a partition of the sample space. Let A be any event of non-zero probability. And in the rough work side I write, not the statement, what and all we know and what we are going to find. See, we already know, when this much is there means, we already know P of E1, probability of occurrence of E1, probability of occurrence of E2, comma so on, probability of occurrence of event E suffix n. We know. These probabilities we know. Not only that, we know these probabilities. Probability of A given E1 we know. Probability of A given E2 we know. And so on. I tell you finally, we know probability of A given E suffix n. If this much we know everything, then what are we going to find in Bayes theorem? In Bayes theorem, what is required is the probability of getting maybe an event E1 or E2, so on, or E suffix n, given that the event A has already occurred. That means what? Our aim is to find what? Our aim is to find either probability of E1 given A, this one, or probability of E2 given A, or so on, so on. In general, our aim is to find, probability of E suffix I given A. This is called reverse probability. So we are finding in Bayes theorem something called reverse probability. I will tell you the meaning of reverse probability later, slightly later, with the help of an example. Now again I will tell in words. What is required is the reverse probability of getting a certain event E1 or E2 or E3 or so on, or E suffix n, assuming that event A has already occurred. That is, in general, this formula I am going to write. So this is my rough work explanation. Now please understand what formula I am going to write. So therefore we find P of EI given A, and the formula numerator is P of EI into P of A given EI divided by denominator is the total, that is the total multiplication theorem on probability, which says P of E1 into P of A given E1 plus P of E2 into P of A given E2 plus so on, and plus P of E suffix n into P of A given E suffix n, where 1 less than or is equal to I less than or is equal to n. Of course, this formula Bayes theorem, when I give it for n number of events, it looks difficult. But don't worry, at the second PUC level, we have Bayes theorem exercises based on a partition containing either 2 events or a partition containing only 3 events. More than 3 events we do not have. Therefore, when the partition contains exactly 2 events, then this formula will be very simple. It will be either probability of E1 given A or probability of E2 given A. That I will give you slightly later. Similarly, when the partition contains exactly 3 events, E1, E2, E3, then the formula will be either probability of E1 given A or probability of E2 given A or probability of E3 given A. I request you kindly go through this much. Now students, kindly note down very important formula I would like to give. That is from Bayes theorem, but if the sample space has a partition made up of two events. Assume two events. Say, let the sample space S contains only E1 union E2. That is this set containing E1 comma E2, only two events. Say, we don't go for n number of events because it is difficult. Let us go for two events, only two events. Let the set containing E1 comma E2 be a partition of our sample space yes sir, and let capital A be any event of non-zero probability. This much I have written means, do you know, while solving sums, what and all details we know? See, I will write in the rough. Whenever I write something in the rough, I have a practice of writing the spelling of the word rough as RGH, short form. Say, this is my rough work. See, I know if I write these two things means I know four probabilities. You know, we know here probability of E1, comma, probability of E2. We know. Also we know probability of A given E1 and probability of A given E2. These four probabilities we know. Then what we should find using Bayes theorem? To find, I will write here. To find either P of E1 given A, or P of E2 given A. This is the purpose of Bayes theorem, and that is called reverse probability. So again I tell you, what is required is the reverse probability of selecting maybe the first event, assuming that event A has already occurred. Say, later I will explain same thing with the help of one example. But before that, I would like to give two formulae. One for this, another of this. Listen kindly and note down. That is, first formula is, therefore, if you want to find P of E1 given A, your formula should be P of E1 into P of A given E1, this whole thing divided by P of E1 into P of A given E1, this plus P of E2 into P of A given E2, P of A given E2. This is one formula. Kindly by heart, very important. Not only that, I would like to give another one. Say, P of E2 given A could be written. Say, denominator do not change. Please remember, denominator same even for this. P of E2 given A. P of E1 into P of A given E1 plus P of E2 into P of A given E2. Denominator same, but numerator you should change. Which one we want? Which reverse probability we need? We need probability of E2 given A. Therefore, it is P of E2 into P of A given E2. This is the numerator. So I request you, whatever you have understood from this and whatever I explained previously, partition, Bayes theorem, etc., mainly remember these two formulae, and what I am guessing is this year annual exam using the one of these formulae, one exercise for 3 marks, 99% sure, or an exercise which is there for 3 events, which I will again explain later. This much kindly go through. So if the sample space S is made up of a partition which contains 3 events, say E suffix 1, E suffix 2, E suffix 3. Let A be any event of non-zero probability. Now I do not write on the rough work side what and all we know. Instead, orally I will tell you. We know probability of E1, probability of E2, probability of E3, and also we know probability of A given E1, probability of A given E2, probability of A given E3. What we should find? Here also we should find reverse probability, but 3 reverse probabilities could be possible. Hence I will give now 3 formulae. Say, kindly note down. First reverse probability is probability of E1 given A. So, denominator is a big total. Total of 3 probabilities. Say, P of E1 into P of A given E1 plus P of E2 into P of A given E2 plus P of E3 into P of A given E3. And what the numerator is? Which probability we need to find? Probability of E1 given A. Therefore, this is probability of E1 into probability of A given E1 is the numerator. Similarly, there is a second form. Suppose we need P of E2 given A, then this could be written numerator this P of E2 into P of A given E2. Denominator is the same. I will repeat. P of E1 into P of A given E1 plus P of E2 into P of A given E2 plus P of E3 into P of A given E3. There is one more reverse probability is possible. That is P of E3 given A. So numerator changes into P of E3 into P of A given E3, and denominator is once again the same sign. P of E1 into P of A given E1 plus P of E2 into P of A given E2. This plus P of E3 into P of A given E3. So I request you, please study these 3 formulae or study any one of these 3 and they are similar. Suppose they ask you to find the conditional or the reverse probability of occurrence of event E1, assuming that event A has already occurred, then this is the formula. Here the reverse probability of finding the probability of occurrence of event E2, assuming that event A has already occurred. Here, finding the reverse probability of occurrence of event E3, assuming that event A has already occurred. What similarity you can observe in all 3 formulae? Denominators are same, but if it is P of E1 given A, numerator is P of E1 into P of A given E1. If it is P of E2 given A, numerator is P of E2 into P of A given E2, and so on. So kindly go through this. Now I would like to explain one example to base the theorem containing only 2 events. With the help of this you should able to understand almost all the sums using Bayes' theorem. Let us see how it goes. See, assume that there is one box 1. Say, a box 1 containing or contains 3 red and say 9 black balls. Another box 2. Assume box 2 contains say 5 red and 5 black balls. See, these are the 2 sentences. Only 2 boxes, box 1 and box 2. Meaning is there are only 2 events, E1 and E2. And do you know what is event E1? E1 is selecting box 1. And do you know what is event E2? E2 is selecting box 2nd. Out of what is probability of E1? Out of 2 boxes, you select 1. So 1 by 2, half. What is probability of E2? Also 1 by 2. Now I define the special event that is called A. Always remember, usually later after this I will give the first question from the model question paper. Always the last but one sentence in the question defines the special event capital A. So here the event A is this. Say, one ball is drawn. One ball is drawn which is found to be red in color. Assume found to be red. Now this is special event. And now the question is, last sentence. Please do not copy this question. What is the probability? What is the probability that this ball is drawn from bag say 2. Now, suppose this is the question. Assume, say, I will first tell you there are 2 events, E1 and E2. What is event E1? Again I will tell you there are only 2 boxes. Say, box 1, box 2. So what is event E1? Event E1 is selecting box 1. Say right here. Selecting box 1. So what is implies P of E1? Probability of E1. How many boxes are there? 2. So denominator 2. How many boxes we select? 1. So half. What is E2? E2 is selecting box 2nd. 2. Therefore, what is probability of E2? This is also half. Now I define special event. Let the special event A. Special event, I said, always the last but one sentence in the given question is the special event. Say, last sentence is starting from here. What is the probability that the ball drawn is from back to? Which is the last but one sentence. So this is the last but one sentence. One ball is drawn which is found to be red. Therefore, selecting or drawing a red colored ball is the special event A. So I write here, it is drawing a red ball. And now immediately we know these things. Therefore, probability of A given E1. What is the meaning of this? I will decode. This is conditional probability. That is, E1 means the event has already occurred. That is, you are selecting box 1 and you are selecting a red colored ball. Red colored ball from box 1. Let us come back to the ratio. Say, in box 1, there are 3 red colored balls. 3. So, numerator 3. So, 3 by denominator, there are total number of balls available in box 1. 3 red, 9 black. So, 3 plus 9. 3 plus 9. So, it becomes 3 by 12. That it becomes 1 by 4. On the other hand, I will find out P of A given E2. Means, what is the meaning of this? That is, the box is a second box, E2. That event has already occurred. That is, the selected box is the second one. But we need a red ball from second box. See, there are how many red balls in second box? 5. So 5 divided by, then there are total number of balls how many? 5 red, 5 black. So 5 plus 5, 10. So it is 5 by 10. This is 1 by 2. Now I will continue over here. What is required for us? We require that of reverse probability. I repeat once again. What is required is the reverse probability of selecting that of ball from bag to, say, selecting from bag to, given that the ball is red in color, ball is red. So this is what we need. So what is required is, say, the ball selected is already red in color. This event already took place. See, what event already took place, I write on the right side of the line. But it should come from back to. What is the event selection of back to denoted by E2, right? So P of E2 given here. And what is the formula I had given previously? The formula is P of E2 into P of A given E2. This divided by total P of E1 into P of A given E1. This plus P of E2 into P of A given E2. Now I will substitute. See, P of E2 is here half into P of A given E2. See, this is also half divided by this P of E1 is half here, half into P of A given E1 is here 1 by 4 plus P of E2 is half into P of A given E2 is half itself. Therefore, numerator becomes 1 by 4, half into half. Denominator half into 1 by 4, 1 by 8 plus 1 by 4. And this, if we could simplify, this is 1 by 4. This becomes 1 by 8 plus 2 by 8. So 3 by 8. So 1 by 4 divided by 3 by 8 here. Because 8 LCM. Here 1 plus 4 goes 2 times. So 1 by 4 multiplied by 8 by 3. Hence, answer is for this 2 by 3. So this is just an example. But this type of sums itself appear in final exam for 3 marks. So kindly go through the solution. Now let us begin with the exercises from model question paper. See, this is question from model question paper 1 based on Bayes' theorem. Kindly go through the complete question. There are 2 boxes. See, only 2 boxes. The moment you read these 2 words, 2 boxes, you have to understand that there are only 2 events, E1 and E2. E1 is the event of selecting first box. E2 is the event of selecting second box. I will continue reading, namely box 1 and box 2. Full stop. Box 1 contains 3 red and 6 black balls. Box 2 contains 5 red and 5 black balls. One of the 2 boxes is selected at random and a ball is drawn from the box which is found to be red. That becomes the special event. I told you previously in the same video that not the last sentence but the last but one sentence will help us to define the special event A. Here what is the last sentence? Last sentence is this: find the Probability that the red ball comes out from the box 2. Read the last but one sentence. Which is the last but one sentence? Say from here. Last but one sentence. One of the two boxes is selected at random. Ignore that, don't worry. And the ball is drawn from the box which is found to be red. This is special event which is found to be red in color. Therefore, first I will begin like this. Say, let E1 be the event that the first box or box 1 is selected. Let E1 be the event that box 1 is selected. Therefore, what is P of E1? I mean probability of occurrence of event E1. How many boxes are there? 2 boxes. That 2 in the denominator. How many boxes we select? 1. So 1 by 2. Similarly, event E2. Say the box second 2. This is selected. Okay. Therefore, what is probability of E2? Once again tell me. Denominator 2, right? 2 boxes and only 1 box is selected. 1. Now I will define special event. Let A be my special event. What is this special event or which event we call it A? Again I will repeat. If anybody has not understood, please follow carefully. Not the last sentence. Find the probability that etc. Not the last sentence. Read the last but one sentence. Which is the last but one sentence? One of the 2 boxes is selected at random and a ball is drawn from the box, one of the box, which is found to be red. So getting a red colored ball is special event. So I will write. So it is getting a ball which is red. Therefore, what is the probability that it has come from bag 1? Means I want to find P of A given E1. What do you mean by this? How do you decode this A given E1? Event E1 has already occurred. What is the probability of occurrence of event A? Event E1 is what? Box 1 is selected. And what is the probability of getting a red ball from box 1? From box 1. Please count how many red balls are there in box 1. So there are 3. So 3 in the numerator divided by total number of how many balls are there in box 1. So 3 red plus 6 black. So 3 plus 6. Say 3 plus 6. Therefore it is 3 by 9. So 3 goes in 9 3 times. So 1 by 3. Same time, what is probability of A given E2? How do you decode this? Meaning is what? Meaning is it should come from box 2. That is box 2 is selected, but the selected ball should be red in color. Okay, go to box 2. In box 2, there are 5 red balls. That is the numerator 5 divided by how many total number of balls there in box 2? 5 red plus 5 black. So 5 plus 5. So 10 it is. So 5 by 10. This is half. Now the remaining part of the answer I will continue over here. It is a slightly lengthy sum. Now what is required? Now read the last sentence. Say, I will repeat. Read the last sentence now. Find the probability that red ball has already drawn, but it should come from box 2. Means it is nothing but calculation of reverse probability. Which reverse probability? That I will write as required. So required is this probability of which event already took place, that I should write after the line. Say I have to draw a vertical line, small vertical line. Okay, and the event which already took place. Which event already took place? The selected ball is red. Selecting red ball is the event name A. A here. But it should come from box 2. Which event indicates that box 2 is selected? Say E2. E2 here. And now I had given the formula previously in the same video. P of E2 given A is P of E2 into P of A given E2 divided by P of E1 into P of A given E1 plus P of E2 into P of A given E2. And let us substitute and simplify. Say P of E2, say over here half into P of A given E2 is also half divided by P of E1, say here half into P of A given E1, say 1 by 3. 1 by 3 plus this is half into half. Therefore this is 1 by 4 by 1 by 6 plus 1 by 4. This is 1 by 4 divided by, this is 12 LCM, 6 2 times, 4 3 times, so 5 by 12. So I will continue here. It's 1 by 4 divided by 5 by 12 is multiplied by 12 by 5. Therefore 4 goes 3 times. So I think final answer is 3 by 5. So this is 1 by 6 plus 1 by 4. 12 LCM. 6 2 times. 4 3 times. So 5 by 12. So 1 by 4 divided by 5 by 12 multiplied by 12 by 5. So 3 by 5. So this is one sum carrying 3 marks. Kindly go through the solution. Here is the next question from model question paper 2. Kindly go through the complete question. Of the students in a college, it is known that 60% reside in hostel, 40% are day scholars, means they do not reside in hostel. Previous year results report that 30% of all students who reside in hostel attain A grade and 20% of day scholar attain A grade in the annual examination. So let us choose first of all event E1 and event E2. Event E1 is a selected student who resides in hostel. Say I start solution here. Say event E1 or the student who resides in hostel. Please understand, very easy question. Therefore, what is probability of event E1? See, how many reside in hostel? See, 60%. Therefore, we do not write P of E1 as 60. We should write it as 60 by 100. Which is 20 goes 3 times, 20 goes in 100 5 times. So 3 by 5. Event E2, student who is a day scholar. See, student who is a day scholar. Let us see what is the probability of occurrence of event E2. See, how many day scholars are there? Say here, 40% are day scholars. So it is 40 by 100 we should write. 20 goes in 42 times, in 100 5 times. Now, I said in the previous sum or in the same video, please read the last but one sentence. That gives you the special event A. So here, the last sentence is here. That is, what is the probability that the student is a hosteler? Whereas look at the last but one sentence. At the end of the year, one student is chosen at random from the college and he has an A grade. Therefore, a student who has secured A grade is a special event A. So I will define here. Event A is a student who has A grade, who has grade A or A grade. Now therefore, what is probability of A given E1? How will you understand this when I write like this mathematically? Meaning is, what do you mean by event E1? Event E1 has already occurred. What is the probability of occurrence of event A? Now, what do you mean by saying event E1 already occurred? Student is residing in hostel. What is the possibility that he secured A grade last year? Let us check. See, 30% of all students who reside in hostel attain A grade last year. Say 30%. Therefore, it is 30 by 100, which is 10 goes 3 times, and in denominator 10 times. Same time, let us see P of A given E2. What is the meaning of this? Its meaning is event E2 has already occurred. What is the probability of occurrence of event A? Meaning is student is a day scholar. What is the probability that he secured A grade last year? See here, 20% of the students, day scholars who attained A grade last year. So it is 20 by 100, which is nothing but 1 by 5. Now, remaining part I will continue over here. Please understand, the thing is, here the important thing is, now read the last sentence. Last sentence is, what is the probability that student is a hosteler provided he has A grade? Or I will request you start reading from here. At the end of the year, one student is chosen at random from the college and he has an A grade. That means I will write here required. Required is a student has A grade. A student already secured A grade. That event already took place. So it is event A already took place. But now we are cross-checking what is the probability that the student is a hosteler. Where is the event that a student who resides in hostel? It is event E1. So E1 given A required P of E1 given A, and formula is P of E1 into P of A given E1. This whole thing divided by P of E1 into P of A given E1 plus P of E2 into P of A given E2, and let me substitute. Say P of E1 here 3 by 5 into P of A given E1 3 by 10 divide by, this is P of E1 3 by 5, P of A given E1 3 by 10, this plus P of E2, see 2 by 5 into P of A given E2 is 1 by 5, and this we can calculate. I'll continue. It's a simplification over here. Numerator, you could say it is 9 by 50. Denominator is 9 by 50. This plus it is 2 by 25. And you can go on simplifying. The final answer is 9 by 13, because this is 4 by 50. 50 LCM cancelled. 9 by 9 plus 4, 13. So 9 by 13. Kindly go through the solution. Here is the third question from model question paper 3. Read, given 3 identical boxes, 1, 2 and 3, each containing 2 coins. Full stop. In box 1, both are gold coins. In box 2, both are silver coins. And in the box 3, there is 1 gold and 1 silver coin. A person chooses a box at random and takes out a coin. If the coin is of gold, what is the probability that the other coin in the box is also of gold? So first difference I tell you, compared to the previous 2 exercises, in this exercise we have 3 events, not 2 events. That is 3 events I will denote by E1, E suffix 2, E suffix 3. So I will start writing. Listen. Say event E 1. Say, first box is selected. So, therefore, what is the probability of occurrence of event E1? How many boxes are there? 3 boxes. In that first box, so numerator 1. So, 1 by 3. Event E2, second box is selected. Therefore, probability of E2 again 1 by 3, and there is event E3. Event E3 is third box is selected. So in this we have probability of E3 again 1 by 3. Therefore there are 3 events. Each have probability 1 by 3 each. Now I want to define the special event. Special event is called or denoted by capital A. It is the event you get by reading the last but one sentence. So read the last but one sentence. The last sentence is this. It is from here, you may assume. What is the probability that the other coin in the box is also of gold? Or this one you may consider as last but one sentence now. So this actually it is the last sentence only, but a piece of it in the beginning, a piece of it you consider as last but one sentence. That is, if the coin is of gold, that is special event A is selecting a gold coin. So I write here, special event A is selecting a gold coin. Yes, this is the special event. Therefore, please tell me what is probability of A given E1. What is the meaning of it? That is, box 1 is selected, and from that we have to select gold coin. So go to box 1. Say, in box 1, both are gold coins. So how many coins are there? 2 coins. Therefore denominator 2. And what is the numerator? I need gold coins. And they said both gold. So 2 by 2. It is 1. Whereas remaining part, I would like to continue over here. What is probability of A given E2? Meaning is, select the second box, but we need a gold coin from second box. Let us read. Say, in box 2, there are 2 silver coins, both silver only. That is denominator 2. But I need a gold coin. But there is no gold coin in second box, both silver. So numerator 0. 0 by 2, 0. Then probability of A given E3 is, go to third box. Third box is here. See, box 3. There is 1 gold and 1 silver. So 1 plus 1, 2. Denominator 2. In that 1 gold coin. Now let us identify what is required. Required is, now read the sentence from here. What is the probability that the other coin in the box is also of gold? Or in other words, if the coin we picked is already of gold, means event A, selecting gold coin, already took place. So this event took place. I will repeat. Say, if the coin is of gold, means the selected coin is of gold. Which event defines the selected coin is of gold? Say event A, selecting gold coin. So that event already over, took place, occurred. Now, what is the probability that another coin in the box is also of gold? That means, which box is that which contains both gold coins? Selected one gold, other one also gold. Which box is that where both gold coins? It is nothing but box 1. Box 1, both gold coins. That is event E1. So I need probability of E1 given A. And let me write the formula. It is P of E1 into P of A given E1 in the numerator, and denominator is a little bit lengthy sum here. So I will start from here. P of E1 into P of A given E1, this plus P of E2 into P of A given E2, and this plus here P of E3 into P of A given E3. Now quickly let me substitute. Say P of E1 1 by 3, this is into P of A given E1, see this 1 divided by denominator, this is again 1 by 3 into 1 plus P of E2 again 1 by 3 into P of A given E2, say over here 0 plus P of E3 again 1 by 3, P of A given E3 is half. Therefore numerator is 1 by 3 into 1 by 3. Denominator is 1 by 3 into 1 by 3. This is middle term 0. This is plus 1 by 6. Hence, this 1 by 3 I can write 2 by 6. Therefore 1 by 3 by 2 by 6 plus 1 by 6. That is 3 by 6. So 1 by 3 by 3 by 6. Or in other words, 1 by 3 multiplied by 6 by 3 it is. Therefore it is becoming finally 6 by 9. Therefore final answer is 2 by 3. I will repeat, 1 by 3 multiplied by 6 by 3. Yes, 6 by 9, which is 2 by 3. Kindly go through the solution. Here is a very important question. Hence I would like to discuss. This question was there in last year's model question paper. A man is known to speak truth 3 out of 5 times. He throws a die and reports that it is a 6. Find the probability that it is actually a 6. So here also we have two events, E1 and E2. So here the probability, here read the last sentence. Find the probability that it is actually a 6. See, let E1 be the event of getting number 6 when a die is rolled once. Say I write here. So a die is rolled once. Therefore, the sample space contains outcomes 1, 2, 3, 4, 5, 6. You know, in this, let E1 be the event of getting a number 6. So what is probability of E1? What is the denominator? Denominator, there are 6 outcomes, and in that number 6 is 1. So 1 by 6. Then let E2 be the event that getting a number other than 6. Getting a number other than 6. So other than 6, which are the numbers could be possible? Other than 6, it could be 1, or it could be 2, or it could be 3, or it could be 4, or it could be 5. So 5 numbers possible. So 5 by 6. Now let us define special event. Let A be the special event. For that, again you read the last but one sentence. Last but one sentence, he throws a die, and not that, but read from here. And he reports that it is a 6. So the person reports that it is a 6 is the special event. So I write, he reports that it is a 6. Therefore, now let us find out P of A given E1. Now let us decode this properly. What do you mean by event E1? Event E1 is getting number 6. And what is event A? he reports that it is a 6. That means event E1 is getting number 6. He reported also it is a number 6. Both 6, 6. That means it looks like he speaks truth. I will repeat. It is getting number 6. He reports that it is 6. That means what they got 6. He reported it is 6. That means it is something like he spoke truth. How many? What is the probability that he speaks truth? So it is given here 3 out of 5. So 3 by 5. 3 by 5. But what is probability of A given E2? What is E2? E2 is the event of getting a number, not 6. Means getting number either 1 or 2 or 3 or 4 or 5. But he reported that it is a 6. That means he is speaking lies. Understand? He lies. That is, he didn't get number 6, but he says it is 6. So it is a lie. So it is nothing but therefore 1 minus the probability of speaking truth. 1 minus 3 by 5, which is 2 by 5. Now remaining part I will continue over here. Let us see what is required. Required is probability that, say, read the last sentence. Find the probability that it is actually a 6. Means the event of getting 6 took place. Event A took place. And it is actually a 6. Getting number 6 is E1. So P of E1 given A. So formula, you know, P of E1 into P of A given E1. This divided by P of E1 into P of A given E1 plus P of E2 into P of A given E2. Hence, let us substitute. Say P of E1 1 by 6. P of A given E1 is 3 by 5 divided by, this is 1 by 6 into 3 by 5 plus P of E2 is 5 by 6. 5 by 6 into P of A given E2 is 2 by 5. So numerator is 3 by 6 into 5, 30. In denominator 30 LCM. Numerator is 3 plus 10. Therefore 30 gets cancelled. So final answer is 3 by 13. So kindly go through the solution. Also please watch my YouTube channel for more videos. Like the videos, then share the videos with others and subscribe the videos. So next video, let us start with the new lesson, new topic. Kindly go through the solution.